Hello, and welcome back to another episode of Agritecture's travel-free digital conference series in response to COVID-19. I'm really excited about today's talk because I'm going to be talking with a friend and someone I met at some previous events, Richard James MacCowan. And hopefully I did pronounce that okay, James. Richard, sorry, how are you doing?
Yeah, not bad. Currently managing the madness here in Yorkshire in England with two kids at home, trying to keep them amused.
Yeah, I mean, that must be really difficult. I don't have any kids, so it's already has its own challenges working from home, but that must be extra challenging. I guess one of my questions just to begin with is, what's something that you have extra time for now in the wake of COVID-19 you didn't have before?
What have I got? Whoa, that's a tough question. Yeah, actually, spend more time with my children.
Yeah. I mean, I was watching this really kind of inspirational video that someone had made, and it was kind of talking about this period of time in humanity and how it's the time where we started taking our health seriously. It's the time where kids grow up remembering when mom and dad were home all day long. And it kind of brought up all these positive things from it. So that's what we're trying to do here is we're trying to focus on some of the positive aspects of this whole crisis. And certainly we're really excited to share all your knowledge with the world through our digital conference series. If you haven't watched previous episodes of Agritecture's digital conference series, you can find them online at youtube.com/agritecture or agritecture.com/digital-conference. If you like this video, you can like and subscribe, but you can also comment. You can ask questions. We'll pass them on to Richard, and we'll be sure to try and answer them ourselves. So feel free to get engaged. Today, we're going to be talking all about biomimicry applications to our food system. So with that said, I'm going to pass it on to Richard, who's going to give us our presentation.
There we go. For anyone who's not seen Henry's Instagram blog, that is hat 4. It's kind of an inside joke, but public at the same time.
Well,
So yeah, I've got to, when I like playing around as a designer, I've always been quite interested in learning from different things. And kind of my interest in environment, sustainability, and biomimicry came up when I was growing up, and we used to spend summer holidays on Loch Fyne, and this is the west coast of Scotland. Probably the one and only picture you can probably find of blue skies and not swarms of millions of mosquitoes and midges attacking you from all sides. And it was from that area that I kind of learned about the importance from my grandparents about the importance of systems, natural systems, living systems, how they're all connected together. How keeping the streams and the burns that we run into the loch clean and making sure the right plants around there, and making sure that the forestry above that was actually important, how that would impact, and all the way down into the sea loch that Loch Fyne was, even down to the fact that there was disease spread around the loch by the introduction of fish farms. So big industrial fish farms would actually then cause increase in bacteria, parasites that was spread around the wild fish in the area. It was kind of that important thing that it's kind of always stuck through my work. There's working in the real estate sector, urban design, now into biomimicry and looking at food systems and everything like that. So I'm always curious about where do you look for ideas. We all look around ourselves, around where we live, looking books, outside when we can get outside at the moment. For inspiration, whether it's new patterns, looking at skies, looking at plants and animals. Why don't we just delve a little bit deeper and actually looking at how does nature overcome these problems? That's in essence what biomimicry is. So what I'm currently working on is looking into the food systems of biomimicry, but there's various other areas which we'll touch on in this presentation. So what does me and my colleagues do? So what we do, there's actually a number of strands to the business, and Biomimicry Innovation Lab is a new addition to this, which is a consultancy angle focusing mainly on city systems, so actually then looking at the city region as well. And this came out from Biomimicry UK, which is a non-profit, and that very much gives outreach. So we're doing teaching in universities to workshops and webinars and public speaking. And it's where I actually met Henry when we were living at large in Yekaterinburg in Russia. But one of the other projects that spun out of that is called Smart Stable Limited, which is actually looking into, in effect, it's biophilic design or smart city development for horses. So we're looking at the well-being of horses and how they can mitigate the stress impact, especially racehorses have, being cooped up almost 23 hours a day, which is quite interesting considering the fact that this is where actually we all are around the world at the moment. And from that, we're actually then looking into kind of wearable technologies. We're also looking into low-cost ways of growing vertical walls, vertical farming for horses. It sounds a bit crazy, but we're looking into nutrient levels of how do horses self-medicate to minimize the stress and increase the water uptake. So as I mentioned, we look to nature. So, but our key thing is looking, how do we help innovators develop better solutions by looking to nature? Because it's not also about the new solution. How do we just take a product and help them improve it? Whether it's a drain cover for watering street trees to looking at systems in cities or new factories, areas like that. And three key areas which we expand on when we work with clients, taking the problem, really defining it, finding out what is the customer's unmet need to actually make sure we're designing the right thing. And identifying that and taking that through from also the technical challenge and then what biological strategies they can solve that as well to move forward to actually then prototype. I'll say none of these things are actually linear format, but this is kind of our 3 steps. So who have we worked with in the past? Just a random assortment in the UK, some charities like the Prince's Trust to areas like the Biomimicry Institute in America, with universities in Germany and Greece, through to TV appearances on the BBC country file and programs we're doing with the World Service and podcasts, through to work with them doing presentation and work with NASA looking into developing new technologies. So kind of cover areas we're just working on quickly, which I'll get into. So we're working in food systems up in Yorkshire, which we're looking at scaling up. And we're part of an advisory board for adaptive cities through nature-based solutions, which is a European-wide network, looking at how that can mitigate climate impacts on cities. So we currently have 20 members, cities involved with that, plus universities and consultants. I currently teach product design at a university in Greece, working through various strategic ways to actually make sure that things can be manufactured as well as be possible for companies. Other areas is working in advanced manufacturing for organizations in the Middle East. We're currently waiting to hear back from a funding organization to see how we can fund the post-harvest loss for projects in Uganda. We're working with partners to develop a technology hub in Ghana, which will be supported by MIT, and that is a big smart city development proposal. It's going to be powered by as much solar energy as possible. And finally, we're working with a company and with our design team in that based in Cape Town to build in storytelling and biomimicry with various partners around the world who are experts in car design, architecture, and various things like that. So what is biomimicry? Biomimicry is look at how nature solves problems and explore these systems, the processes, and the functions to actually see how can we take those underlying elements and translate them, those principles, into our technologies in a way of designing business models and systems as well. So the best ways to do is look at your hand, look at your hands, and look at how the skin is a different thickness and texture in the back of your hand as well as your palm of your hand, and notice how it stretches and flexes. And how does that solve the problem? It protects you from germs as much as it can, because we can only get viruses spread through our the porous cavities in our body. It holds the bones in place. It's also the back of our neck is a lot thinner than the soles of our feet, and it has different properties as well. It protects us from sunlight as well as that, and it's got some hairs in that, and it regenerates as well. Absolutely amazing material. How could we replicate that? And what you notice if you start delving a bit more is actually what we're looking at is how does nature overcome the problems? Nothing's perfect, so it's about these compromises. What compromises can we actually look at to to maximize kind of the best way that nature does it? So minimizing the negative and maximizing the positive, so to speak. Because when you start looking at it, how do we compare and contrast nature and technology? It's a very, very loose way of doing this, and it's a bit rudimentary at the moment, but if you start looking at it, this is comparing technology and biology in the nanoscale, and it predominantly, most of the time, our technology at that level, we use a lot of energy, where it's adding energy or taking energy away, solve the problem, and then changing the space, so the integration in between pipes or other different metalwork beams and buildings. Whereas in biology, it's different. Energy is very hard to come by, apart from the free energy from the sun, which then converts into various chemicals. But again, that's not very efficient. So nature solves the same problem, by the structure, how it's built up. So think about your bones, trees, anything else that's growing, and the structure and the space between that. Also, as well, is very, very useful that information is embedded into that as well. So effectively what you've got there, you could have an information-rich, lightweight material that's only using the material that's needed to solve the problem. So where have we seen this before? There's a very famous example, if you do a little bit digging, it's just they're ramping up their applications at the moment. And they've actually developed a technology that will actually minimize the spread of viruses and bacteria on common household applications. The company is called Sharklet Technologies. Now, they originally developed their products by some research where they were looking into how do you reduce the drag coefficient of ships in the American Navy. And the guy that was leading the project stumbled across the fact that sharks, especially the nurse shark, does not have a lot of bacteria or parasites on the shark skin. And he started doing a bit of digging. And if you compare that to, say, a whale, which has a lot, if you look at the skin then of a shark, you'll notice that actually it's like little teeth. And you find that it'd be very expensive to print off vast materials like this, but by a lot of study research, they actually looked into this. And what they found is actually it's the mathematical ratios between the bumps and the ridges. And if you lay those out in certain material, in the material, whether it's actually into the product itself or a plastic sheet, which they're now selling, you can actually minimize dramatically the spread of bacteria by just looking at this mathematical ratio between the bumps and the ridges. They've now actually spread this onto their working with companies developing contact lenses as well. As I mentioned, they've really stepping up their sheets that can be then stuck over any applications in houses and hospitals and things like that. So back to the point of what, the reason why I'm here and talking about what do we see as the food system. Unfortunately, that little video is not working. That video should be talking about the fact that we're, like any complex systems, quite often.
Richard, sorry, if you want to say what the video is going to say, which is what you're about to do, but if you want to say what the video is going to say, and then we can play it. If you send it to us, we can do that. So
yeah, I mean, it's a little. Yeah, I can do that, but it's no problem. I mean, what this video is meant to show is a little, complex programs, a bit like complex systems, are liable to break. So we have got a system failure. And also the other thing is we talk about sustainability in a matter of which we shouldn't do, because a lot of people still don't understand what sustainability is. So as it says, sustainability is like teenage sex. A lot of people are talking about it. Not a lot of people doing it, and those that are doing it are generally doing it badly. Which, thank you very much. Good laugh. Because at the moment, people don't really even understand sustainability and all that. Because going back to university, most people will be taught about the three pillars, which is led on to the sustainability development goal. It all should be equal. But the reality is, you're seeing that now, especially, is it's all about the economics. Can we make some money? Where the companies that are really showing their true colours are coming out, and the ones that aren't. It's all about, at the end of the day, people still have to make money as the people, planet, profit. But that's kind of interesting because that's kind of the Mickey Mouse way of really what we're going to do if we're trying to save the world. We need to actually think about those three pillars, but also think about the ecosystems that they're based in, what the ecological impacts, not just the environment. And that very much brings into this idea of we shouldn't just aim for a less bad result. We should actually start thinking about doing something more good. Because we're not just talking about one area. We're not just talking about climate change. For agriculture and food systems, it's about how does the land system change? How does the water, that fresh water that we need, impact on the land systems? How does that then impact in the flow off into the oceans that then causes the change in the oceans that can actually have that big systems impact of the water that's evaporating in the oceans as well, the dying off of species and things like that. And it's all interlinked. Because as we know, we need to feed more people. We need to reduce greenhouse gases and, change the loss of habitat. Look at actually how we're destroying the fresh water and actually polluting it. And the farming, the mass agriculture is actually just destroying the environment close by where the farms are and also downstream as well. But we have to take this at a systems level and think about how they can all tie together. I really like this diagram. It was done by IDEO for their design competitions, and it kind of explains the complexity of a food system. If you start delving and start thinking about, I mean, one of the key areas there that jumps out for me, and anyone else watching this, is actually the consumers, and actually start thinking about, you know, is it the consumers or the food industry that needs changing, or is it both? How do you then go through all the things of tying in the politics and the security of food as well? Who's going to make a decision? Are we followers? Are we leaders? And it's a very, very massive shift. If you think about you changing the use of water, how does that do a positive impact in the land or a negative impact, and all these things feeding through? You can start tying it up and just print it out and start drawing different your own system along the lines as well. So what about biomimicry and how those examples, so I'll show a number of them. So one of my favorite ones is actually a project called the Sahara Forest Project. So it was originally started to look at how can we regrow the Sahara forest. It was developed by an architect and his team at Exploration, working with Arup. And they turned this around by looking into how can we take a systems thinking approach and looking at ecosystems level to grow food and increase biodiversity in the desert by using as little energy as possible. So they started piloting these prototypes funded by the sovereign wealth funds in the Nordics, as well as in the Middle East, to pilot these out in areas that allow for, it's got a lot of solar potential. This is one of their concepts. They've currently actually got a pilot project currently fully running, which is around 20 hectares. And this is the larger concept, which when finished, which includes seawater greenhouses and various other ways to recycle nutrients and things like that as well, actually has the potential to feed the entire country of Qatar with all the cucumbers, tomatoes, peppers, and aubergine. That's 160 hectare facility. With the current pilot project actually producing the same output as commercial European greenhouses, using a lot less energy and actually building in filtering out salts from seawater and filtering it through. I mean, some of the unexpected results is actually they found that the biodiversity increased round about the project a lot quicker than anticipated. So it's kind of knock on that actually the plant species put in, insects, birds, rodents are feeding that, and this kind of whole food web developed a lot quicker, so that the kind of regrowing of the plant life and the habitats around there is happening much quicker. One of the biomimetic ways they did actually look at actually increasing the collection of water is by looking to the Namibian fog basking beetle. It's a little beetle. You think deserts are very dry, but actually there's a lot of moisture in deserts in the evenings with as they change in temperature. And they climb to the top of the dunes and they stick their bum in the air effectively and collect water as the moisture lands on its shell and then trickles down that through the ridges and the bumps into its mouth. And the Sahara Forest Project's done this by putting big black sheets that appear at night above the greenhouses and then collect all the additional moisture from that, so that actually can then filter in, and you're not having to have as much fans going to actually power the seawater greenhouses. So what about plastics and packaging and water? So how do we look at how do we use the right amount of materials? So one of the areas of study is actually looking at how does the materials used in, say, bones and tree growth. And one of the examples is a company called Logoplast. They're working with they design and produce bottles, and they were working with a Portuguese company. And the Portuguese company wanted the lightest plastic bottle, PET bottle in the world, that used existing manufacturing techniques and could be brought to market in 6 months. No insurmountable challenge, I think. You could, but they started looking into biomimicry, and they started looking at where does strength be kept whilst using less energy. And they came across the white pine trees and how they actually twist as they grow. And there's various other trees. I'm sure people want to go out and once they, in their daily walks, can find any other trees that twist and grow as they grow. It's due to generally stresses or high wind levels. And actually, what you find is there's less material there. So taking that, they start looking at the ridges, and through computer modelling, they actually found that they could actually reduce the amount of material and actually keep the same strength. And then the first product was actually released to market. Now, a lot of people sit there and go, why don't they use metal or any other? Unfortunately, you've got a supply chain there and all tied in with contracts. And yes, everybody'd love to move away from plastics. And Logoplast they did actually design the Eco-Vert ocean plastic bottle, other ones, but in this case, they had to use the plastic. So it can be fully recycled. The point here is they actually saved about 5% of material for the first iteration. And then the next one, there was another 5 to 10%, and then the next one, another. So they're continually changing the bottle by taking away material, but keeping the same strength, in some cases making it stronger, just by looking to a tree. And now the Vitalists have actually got this as part of their brand of actually the bottle defined by these bumps and ridges. How weird the videos don't play. Now, I touched on this earlier when we were talking about food webs and ecological webs. Now, in this, you're actually seeing, who eats what decays and then breaks down and get eaten by something else. So, it could be the fox eating the snake, and the snake eating the insects, as well as eating the squirrel and various other things. And it's all built around in kind of this big, large system. And this is a very simplistic model of food web. But it's important here because what you're seeing in here is you're seeing energy transfers and seeing processes happening. So researchers at Georgia Tech have studied this and looked into how can you look into manufacturing processes or city systems and actually compare them. So actually through some mathematical model, you can actually see where in a manufacturing process works well and where does it not compared to a food web. Giving you potential to, how do we improve the food systems or the nutrient recycling cities, so the human waste or anything else feeding through cities, as well as factoring to make sure that they can actually, is there any waste streams that they could actually tap into to actually then, as a secondary output. A bit like British Sugar in the UK using the excess heat and CO2 to grow hothouse tomatoes and now medical grade marijuana, by kind of taking that systems approach. But one of the key things you get from looking at all that is this concept of resilience. It seems to be coming up a lot in the talks and webinars and kind of video calls that I'm doing at the moment. And I'm fortunate enough to work with a company as well called Resilience Brokers. And resilience is about our capacity to adapt to change. Now, Madonna is a great example of a pop star who's adapted to change over her career. And if you all agree, I think that should be, Like a Virgin, should be Henry's next song that he dances to on Instagram.
Request accepted.
There we go. I'm sure you would. So as I was saying, resilience is the long-term capacity of a system to deal with change and continue to develop. And I'm sure a lot of people at the moment, you're seeing systems that are still working. You're seeing systems that are happening in cities where communities are getting together and still making food get to the vulnerable. It's very interesting when you actually look into this. This is very, very similar to an article written by Rem Koolhaas, who's a Dutch architect even back in the 1990s. And he wrote about how Lagos and the government system broke down there and people kept working. If roads had potholes, new roads were created. If markets, the government didn't put up markets, local authorities, they would set up markets anyway and pay the landowner themselves, and the whole system worked. Yes, there was still some negative aspects of a system, like, I'll not get into that, but it meant that the system still happened without government interventions. So we're now seeing through this crisis, in the UK, you're seeing people being helpful, and it's working. The reason why I've got car manufacturing is because Toyota, they love optimization. We want everything delivered just in time. We can get new cars built as quick as possible. Supply chain is brilliant. One problem is they never actually built in redundancy. They never built in actually shocks to the system. So it all works very well and good. When you're wanting to get things done, there's no shock, there's no breakage. Just what happens if there's a natural disaster? Well, everything stops. Well, if you just built in a kind of decentralized network, very much like in the natural world, you can actually find you can bypass these. And yes, you're not optimizing, but life keeps going. And you see that in the natural world. from what we've been talking about to also, this is York where I live, and it floods once a year, and the cities adapt to it. You see the plants along the river are still there. They're holding the banks together. They're holding the man-made structures in place, not the other way around. You're seeing the animals that are adapting and surviving to it and thriving as well. The species that aren't are the ones that don't. So you're actually having this sort of self-organization over time that actually the system is actually adapting and developing to be more resilient. Oh, one of my favorites, it's a shame that doesn't play, I can send it across, is termites. Now, termites are amazing little creatures. They, especially the Namibian termites who build these brilliant, huge fluted termite structures. And they do this by having simple information. They don't have any plans. They don't sit through a planning committee meeting and decide where the entrance and exit should be and everything like that. They just get on, and they're building around the need to have the termite mounds built for 80% moisture because they coexist with fungus. A fungus like this. And the interesting thing, who's in charge? Is it the fungus or is it the termites? And we're still not quite sure. But the point being is they both want 80% humidity. And the termite mound is constructed along those lines. The consensus humidity changes, and then they'll keep constructing. If some of them get eaten, somebody else will come in place and take over. What you see in this video is actually showing how over the change of 24-hour period, the airflow changes throughout the different basically ventilation shafts, and this stacking effect happens where the air is actually moving around to ensure that the humidity levels is kept as constant as possible. But also, the interesting at night, what happens is actually CO2 through the porous membranes of the mounds are actually pushed into the atmosphere, and CO2 is pulled in. So how is that relevant to us, and what kind of things are we working on? So I got together with a number of people in my local city, and we started looking into circular economy and food systems. And we kept thinking, well, how do we develop this, and where do we start? Do we start by developing a product or an individual service? And it kept coming back to, we kept jumping to the food system, because it's great when we have food, but we chuck away 30% of it, as we all know. Food comes from all over the world, but we also think food is grown locally, and actually quite often, chickens, they could come from Asia. Yet a lot of supermarkets want to badge it as that. So it's about knowing where it comes from, knowing the quality, and especially nowadays where you're lacking the basically the food, getting food into countries. How can we grow things more locally to feed the populace? So we started looking around, and we thought, well, why don't we just try and tackle the food system? So we've got a project called Future Food Systems, where we're going to set up an open data trust, where we can start analysing all the procurement strategies and as much information we can get from businesses to see where we can make the most impact. The data will be open, but it's turning that into something useful that they can actually then turn around and say, well, this is where the best strategy, say for a school, local authority has 400 schools that need food, so we can say, oh, by the way, there's a Joe Blogs down the road who's got a piece of land that could be fertile for that. We tell Joe Blogs about this, and then it's connecting people together. And again, it's about understanding the complexity of how does the loss of habitat impact into even poverty reduction, social development of the land in the cities round about. When you're talking about getting rid of bees or not having green infrastructure ecosystem services. So where do I see the future? I really see the future as going back to this termites and how termites are actually working. It's basically looking at complex systems and understanding complexity. Nature is complex, but it also does it without lots and lots of information. It gets on and does it in trial and error, and we should be using that to actually understand how can we test and plan our food systems. And nature is a great way to do that. It can start pushing through, give us actually kind of these benchmarks of sustainability. So looking at how do we benchmark aiming for the sustainable development goals or regenerative design or whatever way we want to look at it. Because the thing is, if you look at all that, it's where do you look for ideas? So why not look a bit closer for ideas and delving into how nature solves problems? And that's everything from me. If you've got any questions, please, yeah, drop me an email, get me on Twitter or Instagram. Unfortunately, I don't do dancing. I'll leave that to Henry.
Stop. My gosh, you're killing me. Uh, Everyone, during the quarantine, I've had to really entertain myself. So don't listen to anything Richard says except for things related to biomimicry. Let's have a virtual round of applause for Richard for that inspiring presentation. I really enjoyed that. Actually, I think we might be able to.
Well
There we
done.
go.
That's really bad. I do apologise. So, Henry and I know each other from last year, and we do actually have a little WhatsApp group called Agritech, where I'd say 99.9% of the time we talk about nonsense, but occasionally some very important things come up. Like our good friend Brett is actually doing some work with the G20, looking at food security in different parts of the world, and those graphs actually, maybe we could ask him to put them in part of this
Yeah, I
talk.
mean, yeah, that content is fascinating. So I will pull that up and see what we can do in post for that. Really, Richard, thank you for that presentation. I mean, explaining what biomimicry is, and I just have some follow-up questions that came to mind for me. I think the first thing was this process of observation, right? That biomimicry begins really observing nature around us, observing patterns and things like that around us. You talked a little bit about some you've noticed, but where did that really begin for you? And kind of what's your advice for someone to start practicing that on a consistent basis?
For me, I've always been interested in the actual world. And it was a school project when I was 15. I started looking at aircraft and flight and really studying how birds fly. And it's very much delving down into the Wright brothers and Da Vinci. But it's just gone on from there. I've had various other detours of careers, but it's kind of always come back to that. How do people get into it? Well, just be curious. Read lots of books. Make friends with a scientist, a biologist. Look at some online courses. We're currently finishing off ours where we've got world-leading experts in that. But just generally read about everything. There's a brilliant guy I know who's he designs supercars, but his kind of thing is he's never bored. Reads about science fiction, history, art, textiles. You never know where you're going to find it from, and then you can start looking to how does nature do that slightly differently.
Yeah, so maybe go ahead.
Yeah, and just have fun and be curious. And yeah, I know it's silly as looking at plants, but then start looking at why has that plant got linear structure, and start looking into that. And actually the structure of the leaf is actually held together. That pushes nutrients around the plant, but it's a sport as well. Whereas we kind of look, say, packaging is separate, isn't it? So how do you build in a cooling system for a packaging? That's all built together.
Yeah, it's really about observing these patterns, these integrated systems, and what they really reflect is essentially evolution over time to some kind of optimization or mutually beneficial situation, like you mentioned. So maybe we can ask our audience to kind of have some fun with this. So, I know many of you are stuck at home inside, but maybe you can find something in nature. Maybe you can look outside, look at some plants in your house or go on your balcony or garden and try to find some kind of pattern or something in nature. Try and observe some biomimicry. And then the rest of the day, when you're probably reading the news or hearing about various problems in the world, try and connect that pattern. Try and maybe match it. Try and see, is there a connection? Is there a solution that I can pull from this pattern that I observed? So there's a little activity that I'm going to practice tomorrow as well. One of the things I found was really interesting was this example of the shark teeth. I think it was shark teeth, right? And
yeah, it was a shark skin, but it does look like teeth. Yeah.
Okay, so the shark skin and these patterns, and that the cost to produce it would be really expensive to solve the problem in the end. And so there has to be this kind of human ingenuity in response to adapting nature to kind of the problem at hand. And that's really interesting to me because, nature itself is going to kind of go through its own evolutionary process to solve the problems, which take a lot of time. But as human beings, maybe we have a unique ability to observe that and accelerate that in a different way. So I guess, can you answer the question, maybe it's an obvious one, but biomimicry isn't so much about copying nature as it is about observing it and then adapting it to some human problem, right? Or it could be.
Yeah.
Can you talk about that a little bit? Okay.
Yeah, so it's talking about, so the example for the shark skin material, it was too expensive to put on the underside of ships and also on aircraft wings, but it's not for contact lenses and that. So they were looking at the principles from that. what's the ratio between the bumps and the ridges and the mathematics behind that? Can that how? And they started playing around with scale. Can it be made bigger or can it be made smaller? Then they found the optimal way that then suits for purpose for testing as well. So it's very much, yeah, it's delving into mathematics. So you're looking at, yeah.
I would think the role of big data then, and how that continues to gain traction, and the actual amount of data available starts to get really, really huge. That's going to be a big asset to kind of utilize biomimicry approaches to apply it to the problems, because you have to understand the problem and have enough data to kind of simulate those possible solutions. So that's kind of an exciting time for biomimicry in that sense right now, right?
Oh, definitely. I mean, when you're looking into how do you find the most relevant up-to-date research. So there's a chap, friend of mine, just finishing his PhD, and he's analysing trade-offs. How does a biologist describe a trade-off in a research paper? And it may well just be a sentence or a paragraph. The rest of it's completely redundant. But he's developed an algorithm that can now basically text mine all the most relevant papers to then find the ones that are actually the most useful. You can then build that into another machine learning algorithm to then help you tap into what the technical challenges, what the engineering solutions, and then you can have them matched up. So in the future, we hope, if we get this right, you will not need to know anything about biology. It helps, but it means you just need to know about your technical problem.
Right, because biology could essentially be online in that data in a lot of ways. So we talked about observation as a step to explore biomimicry, right? Start looking around, start looking for patterns. And it sounds like that's kind of how things began for you as a naturally curious, kind of philosophical person about this topic. But what about somebody who's like deep in business and they have problems in the real world or in their business world? How do they approach it? Should they practice observing, or is there a kind of a reverse way to apply biomimicry where you take a problem and then you look for biomimicry solutions? Maybe a place you can look for examples. What's the method for someone to take an existing problem and go towards a biomimicry solution, as opposed to the previous approach, which was look at biomimicry overall and then kind of look for the problems, which was the previous activity.
The way you've actually mentioned is actually more common, especially in industry, that you've got an existing problem, and that way you can then start looking around. I mean, one example is,
so with
say,
the water bottle, for example, what do you think that process was like, right? They had the water bottle, we want to save plastic. Did they find the solution? How do they find those things in nature?
Well, Carlos spent a lot of time looking at trees outside of his office, and then went on a database that's called Ask Nature and found this white pine tree. But they did a lot of research into kind of material twisting and minimizing use of materials and things like that. Yeah, and it generally is. You've got a technical problem, and then you look to nature, how nature solved that. So it's about breaking down is what problem you're trying to solve. Then also for business, you've got to think, can it be designed? Can it be manufactured? Is it going to make us money? Is it going to tie in all those things as well? Because it's all very well and good saying I'm going to make a brand new water bottle out of a biomaterial, but the manufacturing process can't handle it.
So going back to the food system, a lot of our audience are entrepreneurs, either currently engaged in the food system or looking to build businesses in the food system. What's some of your advice for the business case? And you made it pretty clear in your presentation, but maybe you could reiterate the business case for an entrepreneur in the food system to look at biomimicry, to make it part of their practice.
I would, yeah, start just delving around and say, what doesn't quite work? What do I want to make? It doesn't have to be a radical transformation. It could be that just little 10%. What am I designing that could be a little bit better? Just say it's a water butt that needs slight improvements. Think that way. Start looking around, building the bigger system and see where you can solve it from. I mean, for the agriculture industry, I'd say look at to soil. Soil science is a big thing, very vast thing, or don't use soil at all. But I mean, that's one of the big things we're I had a previous call today and we were talking about reionizing soil. Because one of the big things is obviously then you can allow for nutrients to grow again, and also actually how do you reintroduce microbes into the soil at a quicker rate than they actually grow naturally.
Yeah, fascinating stuff there. So when you talked about I think it was beetles or ants not beetles, it was ants, I think in Namibia. There were two Namibia examples, holler to Namibia. But the one with the kind of fungus and I think it was the ants working together. In nature, there's winners and losers, right? And in nature, the losers can end up dying, right? Starvation or being eaten by some other bigger creature. Are there ethical considerations in the context of bringing biomimicry into your practice? And how do you balance those out in a human world?
Wow, that's a tough one.
Sorry.
Because if you're looking at the termites, you've got this mutualism going on between the two species who basically got together before when Namibia was a rainforest, a lot more humid. Ethical consideration, I think it's more if you start delving into the biotech and using genetics to reorganize nature, because you're not actually working with nature. You're just learning from it. It's not like you don't need to go and cut up a chimpanzee or chop down a tree. You've got many examples there already that you can look into. There's an interesting project that my company is a small part of, and it's actually 3D printing with termites. Hopefully none of the termites are hurt in that point, but the idea in the future is the termites follow these gases and they want humidity levels constant. So you can have a 3D printer that can help that. Because in the future, if you think about 3D printers as a passive element, it builds like nature, like it builds from small to bigger, and it's a growth model. But I think if you made a 3D printer that senses the environment, it builds and creates by sensing, and you don't need to do anything bar let it go. It knows what it needs to create. So you could effectively, how do you make a glass that's built by nature where the glass could be never half full or half empty? So it's always there responding to the environment it's in. The environment is changing as well.
Well, thank you, Richard, for your presentation on biomimicry applications to the food system. I really enjoyed it, and we really want to hear from all of you about your thoughts on this presentation, your questions about biomimicry, your questions about applications to the food system, or whatever industry you're in. So please give us a like on this video and subscribe to our YouTube channel. You can learn about the whole series on our YouTube channel or at agritecture.com/digital-conference. Richard, where can people learn more about you? I hear you have a really cool Instagram account where you post various real things happening in nature that we can observe from biomimicry related. Tell us about that.
I've got an Instagram account which we're very active on. So it's quite often it's latest research going on around the world, which we share. We've also got on our website as well, biomimicryinnovationlab.com, LinkedIn, we're across all social media, and just people get in contact. I like hearing about people's different challenges. We're currently mentoring a little collective of students in India looking at city systems for design competitions. So I'm always interested in helping students out, and anyone's got any questions.
Well, thanks so much, Richard, again. I really enjoyed your presentation when we met in Russia, and it's always been good staying in contact with you. So I certainly hope that you get more attention from this as well on this important work that you're doing. Wishing you all the best, and thank you so much for tuning in to Agritecture's travel-free digital conference.